Today we're going to continue to look and see how we can operate with rational expressions. And today we're going to take a look at a particular type of rational expression known as a complex fraction. This is a fraction that's made up of fractions, which sounds a little crazy and a little bit confusing, but in reality, when we break that down, remember that in algebra, division, a fraction is just a division problem. And you already know how to divide fractions. Your 5th grade teacher taught you how to do this. And if you need a quick reminder, I've embedded a video here in the slides that kind of walks through the reason why we can multiply by the reciprocal to divide by a number. So we remind ourselves that dividing by a number is the same as multiplying by its reciprocal. If you want to take a minute to take a look at that video I've embedded in your notes, please do that. And then come on back and let's take a look at a couple of examples. So our first example is this fraction, 1/3 over 3 over b. And so the first thing that we're going to do with this is we take a look down our set of steps. If there are any addition or subtraction of fractions in the numerator and denominator to combine those, right now we don't have that. So our third step, write as a horizontal division problem. So we're going to rewrite this as 1/3 divided by 3 over b. Now our next step is we recognize that dividing by this value, 3 over b, is the same as multiplying by its reciprocal. So remember, the reciprocal is an inverse. So the denominator is going to become the numerator. Numerator becomes the denominator. Now I can multiply those. I'm going to take a look and see if there are any common factors in the numerator and denominator that I can divide out before I multiply, so I don't have to try and pull them out later when they're a little bit tougher to find. And I see that there's not. A 1 and a 3, those are relatively prime. B and 3 have no common factors. So 1 times b is b, 3 times 3 is 9. And so this expression, 1/3 divided by 3 over b, that simplifies to b over 9. Let's try another one. 2 over x divided by 3 over y. There's nothing to combine here, so we're going to rewrite this. 2/3, the second expression, 3 over y, I'm going to write the reciprocal, y over 3. Sorry, that was 2 over x. Okay. And again, no common factors here that I can divide out, so 2y over 3x. But what about when the expression is a little bit more challenging? Let's take a look at those first two steps again. Combine the numerator into one fraction by adding or subtracting. Denominator into one fraction by adding or subtracting. So if we have to do that, we may have to use the tools that we learned back in 12.2 for combining, adding, or subtracting fractions. Also important to recognize that we may have to remove common factors when we simplify. So let's take a look at this problem. Example number 3. 3 over x plus 1 divided by 5 over x squared minus 1. So let's rewrite this as a horizontal division problem. The reciprocal of 5 over x squared plus 1, x squared plus 1 over 5. All right, well, I recognize that x squared minus 1 can be written as x plus 1 times x minus 1. Now I'm going to have a common factor I can divide out, the x plus 1's. So I multiply across my numerators, 3 times x minus 1. The denominator is just 5. Nothing else there that I can simplify. So we're good with that one. Let's take another step up in the level of difficulty. 1 over x minus 2 And then in my denominator, 2 plus 1 over x. I need to rewrite this first expression, 2, as an expression that has a denominator of x. Well, right now, I can think of that as 2 over 1. Its denominator is 1. I need it to have a denominator of x, so I'm going to multiply the top and bottom of that expression by x. So I'm going to have 2 times x over x. Let's now simplify a little bit more. 1 over x squared. And my denominator now, these two fractions, same denominator, so I can add the numerators. 2x plus 1 over x. Now I can rewrite this as a horizontal division problem. 1 over x minus 2 divided by 2x plus 1 over x. Now let's multiply it. All right, anything here where there are common factors that I can divide out? I don't see any. So my numerator is x. My denominator, I can actually leave in factored form this way, and that will be just fine. Okay. One more, where both the numerator and denominator need to be combined before we can move forward. So in my numerator, 1 over 1 plus 2 over x. Well, I need a denominator of x, and this is equal to 1, so anything over itself equals 1. So that one is relatively easy to simplify. How about here? I have 2, which we'll think of as 2 over 1. I want this to have a denominator of 2x. So I'm going to multiply 2 by 2x, and then the denominator by 2x as well. So 4x over 2x plus 3 over 2x. Combining on the top, x plus 2 over x. In the denominator, 4x plus 3 over 2x. Let's write that as a traditional horizontal division problem. X plus 2 over x divided by 4x plus 3 over 2x. Okay? The reciprocal of my second fraction. And now let's see if we can divide out any common factors. Well, I can see I have an x here and an x here. X divided by x is 1. In the denominator, my only factor is 4x plus 3. Okay. Nothing in common there that we can divide out. You try number 6 on your own. Come back, pause the video, come back and check your work. So with this last example, we had to go ahead and combine both our numerator and denominator. Each had 2 fractions, one being added, one being subtracted. In addition, I had to find a common denominator. I was taking a whole number plus a fraction, or a whole number minus a fraction. So we had to do that conversion as we've done above. If you jump ahead, you can kind of see that, in this case, x plus 2 over x, and then 4x minus 6 over x, the same denominators in these 2 fractions. Eventually, you'll do this often enough that you'll see, in this case, those denominators are going to divide each other out. And so I'll have x plus 2 over 4x minus 6, which we were able to cancel or divide out a common factor of 2, although there was nothing to divide that out with. X plus 2 over 2 times 2x minus 3 is how that one worked out. So we've done some practice together. Be sure to take some time to organize your thoughts and summarize what you've learned from this section. 3 things you've learned today, 2 things you want to know more about, and 1 big question that you still have. You can add in some sketches, connections, any kind of random thoughts, graphic organizer that you want to put together down in this space below.